Okay, so far we are in lecture sheet 8. In the last class, we solved some problem, right? Problem 1, we didn't solve it, but we already solved it in the theory class. That's why I done solve it. Problem 2, 3, 4, we already discussed it, and 2 or 4, we solve it. Now, in Bernoulli's equation, he didn't count the frictional loss in a fluid flow. So you see, in some situation, you can use directly by ignoring frictional loss of the fluid. You can use the Bernoulli's equation because frictional use in those cases very small. So you can simplification, you can neglect. But in reality, you have to count the frictional loss. For example, uh, you are working in a city corporation and you have at least say 40 square mile of city. Now you need to distribute water throughout the city through underground pipeline. So in that case, you need to figure out how much will be loss. Then you need to figure out how much pump you needed. If there is no frictional loss, then what will be happen? You just get the water from the source and put in the pipeline. Then it will go all the way because what Bernoulli is saying that P by gamma, this term always constant. So if this term at a point is 1000, even your pipeline is zigzag or going over the hill, under the hill, right over here you have a pump. Still over here will be 1000 as per Bernoulli's equation. But in reality, it is not feasible. For example, you are delivering natural gas to the Dhaka city from Brahmanbaria or Kumilla. Then obviously, you need to figure out how much will be the loss in the pipe, frictional loss. And obviously, frictional loss will depend on the surface of the pipe and also nature of the fluid, mainly the viscosity of the fluid. If you have more fluid with high viscosity, then your frictional loss will be high. And we can show you by some equation. So how we can correct the Bernoulli's equation? So you see, this is a system, fluid system at point, I choose 2 points, A and B. We are thinking length is L. So it might be 1 mile, might be 5 feet, might be 3 feet, depends. The pipe has a diameter and you see same amount of fluid going through the pipe. So Q is constant. And you look point A and B, they're in the same horizontal line. So in that case, potential height ZA and ZB is same, right? So if I apply Bernoulli's equation without loss, my equation will be this one. But actually there will be some loss. That loss we are saying HLF, I mean hydraulic frictional loss. Now how we can figure out that loss? If simply you apply the Bernoulli's equation between 2 points A and B, then you will see that velocity at point B and A will be same. Why? Because Q equal to A1 or A, area at point A, into VA, equal to area at point B into VB. but area in the both point is same way I draw it. So if you figure out that V equal to Q by A at point A, that will be giving you velocity at point A. Similarly, velocity at point B, Q by area at point B. But this area same. Q obviously is same. So in that case, you are getting VA equal to VB. So this term will be out, this will be out. And ZAB is same. So what will remain then? PA by gamma, PB by gamma plus hydraulic loss. So from this equation, if you figure out the hydraulic loss, you get this mass. That means hydraulic loss equal to pressure difference between 2 points. Now, how can figure out the pressure difference? If you install a pressure gauge right over here, and you install a pressure gauge right over here, then you figure out the difference of pressure. Then you will get the hydraulic loss, right? But if 2 point is 1 mile far from each other, or might be 2 mile, then how will you get the reading? You have one option, you attach some electrical device, say you are right over here, you are looking. Then you're looking in the monitor, right? That's the way they do. Like you are working in a chemical industry, say fertilizer company. They have a lot of system, boiler, condenser, then all the system you have to look through a monitor, right? So they have some sensor. This one after system installation, but you have to design the pipeline. So for example, this is 10 miles. You know the pipe diameter right over here from the design. You need to calculate the how much will be loss. Okay. So let's see how we can figure it out. We say this is the pressure difference between 2 points and location is known. Then we can calculate frictional loss in the pipe. In reality, frictional loss occur due to surface friction in the pipe, viscosity of the fluid, and also type of flow. So 3 factor it depends. Number 1 is viscosity, then type of flow. Is it laminar or is it turbulent? Then depends on the surface friction of pipe. So 3 factor, right? Surface friction of the pipe, viscosity of the flow, then flow criteria, either laminar or turbulent flow. So what happened right over here? Say total summation, if I say right over here is 400. And then right over here, total summation 300, say 80. So how much frictional loss is 20? Okay. For example, you you buy some candy for your younger brother or sister, say 500 candy, but fortunately your bag has a leak, and on the way it drop you one by one. So 30 candy lost in the way. So that means your candy have now 500, 470. So where is the 30? That 30 is the loss in the road, or we can say frictional loss in the pipe. Okay. Now, how we can calculate this frictional loss? So there is some scientists, they derive some equation. Number one is Hazen-Poiseuille's equation, then Darcy-Weisbach's equation, then we have Darcy friction factor. So normally uh, in one semester I derived the Hazen-Poiseuille's equation, but due to the limitation of time, normally I give you the only formula and explain. Because I already told you before that fluid mechanics class actually uh, two class together. Rafi,